In the silent, cold hum of a modern server room, a digital light flickers to life, processing millions of data points spanning 25 centuries. It is here, within the complex circuitry of artificial intelligence, that the past is not merely remembered, but rebuilt. We stand on the precipice of a discovery that reshapes our understanding of the ancient world, peering through the lens of advanced algorithms to witness a marvel of engineering that once decided the fate of Western civilization. This is the story of the Greek Trireme Warship design, reconstructed through AI analysis. A journey that strips away the myths of antiquity to reveal the cold, hard brilliance of a machine that was the stealth fighter of its time. The digital reconstruction begins with a single line, a curvature in a void, slowly forming the keel of a vessel that has not sailed the Mediterranean for over 2 millennia. As the AI model stitches together fragments of archaeological data, ancient textual descriptions, and underwater sonar scans, we are transported back to a time when the Aegean Sea was not a body of water, but a battlefield. The year is roughly 480 BC, and the Persian Empire is rolling westward like a tidal wave, consuming city-states in its path. The survival of Greece hangs by a thread, and that thread is woven into the wood of a ship called the trireme. But to understand why this ship was so revolutionary, we must let the AI dissect its anatomy, layer by layer, peeling back the years to reveal the secrets of its design. The algorithm focuses first on the hull, rendering the wood grain with photorealistic precision. The AI highlights the choice of timber, mostly pine and fir for the planking, with oak for the sturdy keel. This was not random. It was a calculated compromise between weight and durability. The reconstruction shows a hull that was longer and narrower than anything seen before, a slender needle poised to pierce the waves. The computer simulates the hydrodynamics, and the results are staggering. The drag coefficient is incredibly low for a wooden vessel of this size, suggesting that the ancient Greeks understood fluid dynamics not through formulas, but through centuries of intuitive observation and trial and error. They knew that to outmaneuver the heavier, clumsy Persian ships, they needed something that could accelerate with explosive speed and turn on a dime. But the true genius of the trireme, and the most difficult aspect for the AI to model, lies beneath the waterline and within the crowded interior. The simulation moves inside, and the scene shifts from the open sea to a claustrophobic, dimly lit wooden cavern. This is the engine room of the ancient world, powered not by steam or sail, but by human muscle. The AI maps the placement of 170 men, crammed into a space barely wider than the ship itself. It is here that the design reaches its peak complexity. The trireme was not a rowboat. It was a stacked, three-tiered instrument of war. The reconstruction illuminates the intricate arrangement of the rowers, the asterisk 3 knights asterisk on the top tier, the asterisk Zegits asterisk in the middle, and the asterisk THAL, Amites asterisk down near the waterline. Through AI motion capture analysis of modern athletes, attempting to replicate these movements, we see the biomechanical nightmare this ship presented. The oars were not of equal length. The oar holes were staggered. If the timing was off by a fraction of a second, the heavy wooden oars would collide, shattering into splinters and crippling the ship instantly. The AI visualizes the synchronization required, displaying a rhythm chart that looks like the complex beat of a jazz piece. The drumbeat of the ship's officer, the asterisk KELUSTES asterisk, dictated the pace. The algorithm reveals that at top speed, the oars would dip into the water 40 times a minute. It was a heartbeat of violence, a coordinated effort that turned 170 individual men into a single living organism. The digital ghost of the ship highlights the asterisk hypozamata asterisk, a massive thick rope that ran the length of the hull from bow to stern tensioned to prevent the ship from breaking apart under the immense stress of the rowing force. It was a structural brace that computer modeling proves was absolutely essential. Without it, the ship would literally snap in two during the acceleration of a charge. As the digital model rotates, the AI draws our attention to the bow, the weapon of the trireme. This is where the sleek lines converge into a deadly point. The reconstruction renders the asterisk embolon asterisk, or the battering ram, in gleaming bronze. It was not just a blunt instrument. It was an elegant three-fanged claw designed to punch a hole in the enemy hull below the waterline, causing the ship to sink rapidly rather than just breaking the planks on the surface. The physics simulation shows the impact force. Moving at nearly 10 knots, the weight of the trireme behind the ram created a devastating kinetic energy transfer. The AI slows down time to microseconds, showing the wood of a target ship splintering like glass upon contact. This was the primary tactic of the ancient Greek navy, the asterisk periplus asterisk and the asterisk deeplis asterisk. The simulation runs these tactical maneuvers, showing how the triremes used their superior speed to circle around the enemy flanks or crash through their lines in a daring breakthrough. The design was not just about sailing, it was about killing. But the AI analysis goes deeper than just wood and bronze. It reconstructs the social structure embedded within the ship. The rowers were not slaves, as is often believed. Historical data fed into the neural network corrects this misconception. They were asterisk thetes asterisk, the lowest class of free citizens in Athens. And yet, they held the power of the state in their sweat-stained hands. The reconstruction shows us the faces of these men sun-weathered, anxious, determined. Without them, the democracy of Athens would not exist. The ship was a microcosm of the city itself. The AI overlays audio of a reconstructed Athenian assembly, showing how the political rights of these men were directly tied to their service in these vessels. The design of the ship, with its emphasis on equality of effort among the rowers, mirrored the newfound democracy of Athens. We move now to the pivotal moment where this design faced its ultimate test. The AI maps the geography of the Strait of Salamis, a narrow channel flanked by rocky islands. The sun glints off the digital water as the simulation recreates the Battle of Salamis. It is September 480 BC. The Persian fleet, a sprawling mass of over 1,000 ships, blocks the exit. The Greek fleet, outnumbered and outgunned, waits in the shadows of the island. The AI wargames the scenario, testing different variables. It highlights the genius of the Greek tactical decision to fight in the straits. The Persian ships were heavier, designed for the open ocean, with higher sides and more soldiers on board. In the cramped waters of Salamis, these advantages became liabilities. The AI demonstrates how the triremes design its shallow draft, its agility, its responsive steering became the ultimate weapon. The simulation begins. The Greek ships charge. We can hear the reconstructed sound of the asterisk aulos asterisk, the double flute that kept the rhythm, rising above the digital roar of the waves. The AI shows the triremes rowing at full sprint, their rams pointed like daggers. As the Persian ships try to turn, their wide hulls collide with one another in a confined space, creating chaos. The Greek triremes, however, glide through the confusion. The AI tracks the impact points. The bronze rams strike home, shattering the thin planks of the Persian vessels. The water churns with debris. The simulation highlights the carnage not with blood, but with the physics of sinking ships, the listing angles, the rush of water drowning the lower decks. It was a victory of design over mass production, of precision over brute force. The trireme, reconstructed here in lines of code, proved that day that human ingenuity could topple an empire. As the dust of history settles and the simulation moves forward in time, the AI begins to trace the evolution of the trireme. It shows the ship becoming larger, heavier, carrying more marines. The elegant lines of the original design begin to blur as the demand for more firepower overrides the need for speed. The reconstruction highlights the eventual obsolescence of the trireme during the Peloponnesian War and later conflicts. The cost of maintaining these wooden fleets was astronomical, and the forests of Greece were slowly stripped bare to feed the shipyards. The AI creates a time-lapse of the Athenian navy, showing it swelling to an unmanageable size and then collapsing under the weight of its own ambition. The very design that saved them eventually became a financial anchor around the neck of the democracy. But the story does not end with the fall of the fleet. The AI shifts its focus to the modern rediscovery of the trireme. In the 1980s, a team of historians and archaeologists attempted to build a full-scale replica named the asterisk Olympias asterisk. The simulation cross-references the historical data with the data collected from the asterisk Olympias asterisk sea trials. This is where the mystery deepens. The AI flags anomalies. The modern rowers, despite being fit athletes, struggled to reach the speeds described by ancient historians like Thucydides and Herodotus. The simulation highlights friction points, the efficiency of the oar blades, and the physical endurance required to sustain a sprint. It suggests a startling possibility, that the ancient triremes were so perfectly tuned to the physiology of their specific crews, who had trained since childhood, that we with our modern sedentary lifestyles cannot fully replicate the kinetic potential of the original design. The machine was only as good as the men inside it, and those men were a breed that has since vanished from the earth. The AI analysis also delves into the acoustic signature of the ship. By modeling the hull's resonance, the computer generates the sound the trireme would have made as it cut through the water at top speed. It is a low, rhythmic thrumming, a vibration that would have been felt in the teeth of the enemy long before the ship was visible. It was the sound of impending doom. The reconstruction adds the cheering of the crews, the shouted orders of the trierarch, and the crashing of the waves. It is an immersive auditory landscape that brings the static plans of history to life. The AI suggests that the psychological warfare component of the trireme's design was as crucial as its bronze ram. The sight and sound of these synchronized ghosts approaching the shore must have been terrifying. We are brought back to the digital workshop where the reconstruction is nearing completion. The wireframe models are now textured with weathered wood, painted with eyes that stare blindly into the abyss, symbols of the supernatural guidance the Greeks believed they possessed. The AI poses a final question to the void. What does this ship tell us about ourselves? The trireme was a tool of war, yes, but it was also a testament to the human desire to push boundaries. It represents a moment in history where technology, politics, and society aligned perfectly to create something greater than the sum of its parts. The reconstruction shows us that the ancients were not primitive people stumbling in the dark. They were masters of their environment, engineering solutions that still hold up under the scrutiny of supercomputer analysis today. The camera pans away from the completed 3D model, drifting through the digital hull, passing through the rows of ghostly rowers frozen in time, out past the bronze ram, and into the open, simulated sea. The screen fades to black, leaving only the echo of the waves and the memory of the machine that changed the world. The Greek trireme was a marvel of the ancient world, a feat of engineering that defied the limitations of its time. Through the cold, calculating eye of artificial intelligence, we have not just reconstructed a ship. We have resurrected the spirit of an age where the will of free men was forged into wood and bronze and sailed against the tide of history. And as we look at our own world filled with our own complex machines and rising tides of conflict, we are left to wonder if our modern creations will one day be viewed with the same awe, and if we possess the same unity of purpose to row in rhythm when the storm finally breaks.